Hello everyone, welcome to the video. So in this video we are just going to talk about the problems of code forces round 701 div 2 from A to D. Okay, let's start with the directly jump to the problem number A, that's add and divide. In this problem we are given two positive integer a and b, and we can perform two kinds of operation. That is, the first operation is a can be changed to the floor value of a by b, and b can be increment to b plus 1. So we just need to find the minimum number of operations required to make a equals to 0, right? So the question is straightforward and the cakewalk type problem. Okay, so in this problem, how the input is given, there are the test cases from t, and for each test cases there two integers are given, that is a and b, and we just need to find the minimum number of operations. Okay, so let's see the problem and the solutions. Okay, so we can see that if there are two integers a and b. Okay, so when I divide a divides by b, and after this a divides b, and after this when we see constraint, in constraint we can see that the a can be maximum reached to the value of 10 raised to the power 9. Okay, so the maximum value of a and b is 10 raised to the power 9. Okay, so in the worst case scenario we can see that when b is 2, there are maximum about 29 operations, right? That is log a operation, log b a operation. Okay, so if as the problem is a, and we should definitely use brute force approach, because in maximum number of times whenever there is a problem a or b, and also till c, we should use brute force, because these are the easiest problem of the contest, and code forces don't want to make that first three problems to be that difficult. Okay, so when we see that it is a problem and the constraint says that we can use brute force, because the maximum value that this function can reach is 29. Okay, so in the brute force what we can do, that we can just check for each and every value of b till like 30 or 20. Okay, because the maximum answer that can be possible is 29, right? Because if the value of b is 1, if the value of b is 1, then we just need to add 1 is to this, that is 2, and now check for a divided by b, that is 30 or 29. Okay, so what we can do, we can just, in the worst case scenario, it's 30 operations, and we can just check for each value of b from 1 to 30. 1 to 30, that is, we just add 1 to 30 in b. Okay, so we will first check the value of a by b, how many operation it will take to convert, operation it will take to convert a equals to 0, and then we will check for a divided by b plus 1, and then we will check for a divided by b plus 2, and like this we can check till this thing, a divided by b plus I. Okay, so the minimum operation that any will give will be the answer. And one can think that if I am dividing first a divided by b, and then I can divide a divided by b plus 1, right? And after that I can divide by a divided by b plus 2. No, this is not an optimized problem. This is not an optimized solution, because we know that a divided by b plus 1 is always less than a divided by b, always less than equals to a divided by b, right? Because if we are doing this operation after some iteration, after some the type 1 operation, then we can get the minimum operation by doing this type 2 operation before type 1, right? So the code is straightforward, and if I just want to write the code, if you want to write the code, just watch 2-3 minutes, I'll skip the video till that. So in this we just given a test case t, and given a test case t, and after input the t, we can just check for t minus minus, and we can just take answer equals to 100, because our maximum answer can be 30 and 32. Okay, so now I just need to iterate, where's the problem, so I just need to iterate from if I just need to iterate b. Okay, so I just add something to b, like I equals to 0, and I should be less than like 20, and I plus plus. Okay, So now I just find a answer that is my 100, and I will check for each and every operation that temp equals to a. Okay, just I'm just checking, I'm just assigning a to a temp because I just need to iterate for every b, that is b, then b plus 1, then b plus 2, then b plus 3. I have to check for every and each operation. Okay, so now while our temp is greater than 0, just divide temp just divide temp, and temp divide equals to b plus I. Okay, so now the first ambiguity that it can get is if b is equals to 1, right? If b is equals to 1 and uh, if our b is equals to 1, then the loop can go in and go in, right? So I just don't want to check for I equals to 0, because when b equals to 1, then this while loop never ends. Okay, so that can cause an error or something, time limit exceed, that is runtime error type. Okay, after this I just add count to my answer. Count is equals to 0. Initially we just initialize count to 0. This is the maximum number of operation, it is the number of operations that b plus I will take to divide a equals to make temp equals to 0. Okay, and now our answer is must be equals to minimum, right? So answer will be minimum of answer comma count plus 1, because one operation is this I, because one is the incrementation operation, and then the count is the number of the operation, the number of the operation that is the type 2 type 1 operation, right? Number of type 1 operation we will use, that is the count is telling to the number of type 2 operation, type 1 operation, and basically plus 1 is 4 because we have just used type 2 operation. Okay, now in the end we just output the answer. Okay, so that's all in the problem number A. Let's just check for some test cases, given test cases. There can be possibility of some errors. Okay, so it says that count is not defined, declared in the scope. Okay, so what it says, count was not declared in the scope, but it is count equal to 0. Count equals to 0, and while temp is greater than 0, this is okay with it, and answer is this. So and error b was not declared in the okay. Oh, sorry, I just didn't I just forget to take the input of a and b. Okay. Let's try again. So now our a and b are there. I just check for the answer b, then temp equals to a, and it says 242742. Okay, so it's not that correct answer. There must be some error, so let's temp for equals to this, then minimum of count and answer count plus 1. Count is basically the number of the operation of type 1, and count 2 is the number of operation of plus 1 for the number of operation of type 2. Okay, so just check for the first operation, that is 9 comma 2. In 9 comma 2 what we did is first check for the 9 divides by 2. Okay, 9 divides by 2, where is 9 divides by 2? Okay, so first is I equals to 0 and b plus I. Okay, 2 plus 1, first I will check for 2, then I will check for 3, then 4, then 5, then 6. How many numbers it is taking for that? Okay, got it. So here I just need to add I I, because uh, I is telling me the number of type 2 operation. Okay, how many increment I am using, right? So one is I think sum of the error. Okay, so 4 9 2 12 3 1. Okay, so now it's the correct answer. Okay, so we can even submit that solution. Okay, submit problem A, just for checking that the solution is right. So it must be correct because I have already solved it. Okay, so now move to the problem number B. In problem number B, it is asking for the array. Okay, so it is asking for the array. Where is my pen? Okay, so in the problem number B, we have given an array. Okay, so in we have given an array A. We have given an array A and Q queries. Okay, so first it defines us what's a k-similar array. First it told us to what is a k-similar array. So it says that a k-similar array is if it is strictly increasing, that is a of I is equals to this condition. Okay, and the second is the same length of the array, and third is the element are positive integers from 1 to k, and they differ in exactly one position. Okay, so we can solve this question in O1, and that's the quite approach that I get when I was doing the contest. Okay, so in the first input it says given us the size of the array, the number of the queries, and the k with the k length array, and the condition that we have to take in mind is that a of I is always less than or equals to k. Okay, that's an important condition. And the second point is for the each query it gives us the two constant, that is L1 to Li to Ri. Okay, so what's the approach is basically I'm gonna use here. So let me just clear the screen. Erase all. Okay, so in the problem number B, in the problem number B, it says that we have some array. Okay, let's just discuss this problem with the help of example. So in the first example, it say 1 2 4 5. 1 2 4 5. Okay, the array is 1 2 4 5. Okay, so in the first query it says us to just find let us take our query is this 1 2 3 4. Okay, to 2 comma 3, 2 comma 3. Our first query is 2 comma 3. Okay, so when we see that how many similar k similar array are possible, then there are the first case that we get is the all smaller number than 2. Okay, the all smaller number than 2 can be replaced with 2, right? So if my smallest number is 2, then the number of smaller number than 2 are 2 minus 1. Okay, so if the smallest element of this subsequence, okay, of this subsequence is 2, then definitely all the elements that are smaller than 2 will also be smaller than this other subsequence, right? The left out subsequence. Then we can just replace 2 with all the smaller element than 2, right? So in the case 1, I can write I can write that I need to add all these elements. I can make all that array number of array that are smaller than a of L. Okay, so a of L minus 1. Minus 1 is just because that element itself. Okay, so now we just see for the other case, that is case number 2. In case number 2, we just do the same thing that we do in the case 1. Just we need to check for the greater element. Okay, so in the same way, when we just see for the largest element, that is number 4, and there are k elements. Okay, so there are total number of k elements, then we can say that all the elements, that is k minus a of r, k minus a of r elements will be replaceable with the 4. For example, this array is 5, fifth k. Let us assume that k is given 5 for this element. Okay, for this question, for this problem. Okay, so now the largest element we got is 4, so k minus 4 is equals to 1. Okay, so we can make one another array like 2 comma 5 2 5, that is k similar to the given subsequence sub array. Okay, now the most important and the most a little difficult compared to these two cases is case number 3. Okay, in case number 3, what we see that there are total how many elements are possible that can be between these two elements. Okay, what I am trying to say is that let us assume that our k is 5, then 1 2 3 4 5. Okay, so there are total number of 5 elements, but in the array we see only two elements, that is 2 and 4. 2 and 4, right? So there is one element which is not there in the array, and I can replace this element with these two. That is, I can replace with 2, then my new array will be 3 comma 4. That is case similar to the given array. Okay, and the other element, then the other element, the other array is 2 comma 3, right? So these two array are possible. So for each element that is present in between and not in the array, there is two choice, right? So we will add for each and every element. Okay, so let us see with a quite good example, better example than this. There's the second one, second example. That's 2 4 6 7 8 9. Okay, so the 2 4, skip this, 2 4 6 7 8 9. Okay, so let us assume that our sub array is this 4 to 8. Then how many elements are in between 4 to 8? There 1 2 3 4 5 6 7 8 9. Okay, so in 4 to 8 there are 1 2 3 elements. And how many are present here? 6 comma 2, 6 comma 7, only 2 elements. So there is one element that can be present, that can replace any of these, okay, and make two array with it. Okay, so how can we find the number of arrays that are number of elements that not present in the array? It's just simple. It's O1 case 3. What we need to do, we just need to subtract the a of r element minus a of l element minus 1. It's what it tells. It tells us about how many element are present if the array would something like this: 1 2 3 4 5 6 7 8 9. Okay, so if the array is something like this, then there are these many elements in between these, right? But our array, but our given array is something different, like 4 comma 8. This is 4 6 7. Then then how many elements are there in between these array is that I can find through its index, right? 3 4 5. So how many elements present between these two elements is r minus l plus 1. Oh sorry, this is plus 1 because I just had to include these two elements also. Okay, and when I subtract these two things, okay, when I subtract these two equation, I will get the number of remaining elements that are not present in my given sub array, right? You got it? Okay, it's not that difficult. It's just telling us, I'm just finding in the case 3 number of element that are not present in the given array, in the given sub array. Okay, but that can be present if the array is something like this. If my array is 1 2 3 4 5 6 7 8 9, then there are possibly more elements, right? So if this is 3 5 7 8, then I missed 4, right? So if 4 is not there in the array, then I can make 2b array, right? 2 k similar array with this array, right? Because I can replace 4 with the 3 and 5. So I just need to multiply this thing with the 2, because I just need to add every single array count, right? So that's the solution. Three cases: case 1, case 2, and case 3. Okay, the code is quite similar. The code is quite easier. Okay, the code is easy. Okay, so what we in this, we didn't get any test case. Okay, so if I just write the case, okay, so now just it says that int n q k. Okay, c in n q k. Okay, and after this is just give us the array, give us the array that is c in of I. This is a given array, and while the number of queries is greater than 0, then we can just check for the, we will input two elements, c in l and c in r. Okay, now our answer will be, and just declare an answer equals 0, and our answer will be for the case 1 answer plus equals to answer plus equals to a of L minus 1 because it's already given in the sorted order. And for the case 2, our answer plus equals to array of R minus 1. Oh, sorry. Array of, oh no, because this is case 2, so k minus array of. And for the case 3, what we can see that answer plus equals to a of R minus a of L. Okay, so plus 1, basically this that cancel out with another plus 1, and minus R minus L. That is what it will give to us. Just simply see out answer. Okay, so let's check for the test cases. This one 89769. Control V, just compile the code. 74999. Okay, again some error. Okay, so a of R minus L. Okay, it's just opposite. I just need to, because these are the number of element that are given in my array, and these are the present if my array is 1 2 3 4 5 continuous array. Okay, and this is okay, correct, this is correct. Okay, the mistake is because I'm starting my index from 0, my array from 0, and it's giving me from the R and L. That's why it's just giving me the wrong answer, and now we will get the right answer. Again it's 74999. Okay, so what's the error we will making now? We just take the input of the array 24 C in NQK, right? NQK. And we just subtracting two elements, and then just wait a minute. Okay, so the so the error is that I just mistyped that k is the length, the input of the while taking input of the array. I just mistyped that is equals to n. And the second thing is I said that for each and every element that is present in the between of the array, that is not present in the between of the array in our sub array, that must be multiplied with the 2, right? So now it will be multiplied with the 2. Now when we just compile the code, it says right answer 89769. Okay, 897 89769. Okay, so now move on to the next problem, that is problem number C. It's a little bit hard problem, and it also take for me about 30 to 40 minutes. Okay, so in the problem number C, what we see is that what the question tell us that, okay, just let me erase. The question says that a pair of positive integer a comma b is special. Okay, a pair of positive integer a comma b is special if floor of a by b is equals to a mod b. Okay, so it is telling us that a pair of a comma b is special if a by b mod of a by b is equals to a mod b. Okay, so what we see is that, and it's asking us to find the total number of special pairs in the range 1 comma x to 1 comma y. Okay, so let's just solve this question step by step. Okay, so first what we can see that if I assume that x is infinity. Okay, for a let for a simpleness, just reduce this question to a little question, to a simpler problem, that if x is infinity. Okay, so if x is infinity, then a by b equals to a mod b. Then if x is infinity and y is something, okay, y is some value, let us suppose 10 or 10. Okay, so at max how many are possible that make this pair? Okay, if x is infinity, then I can take a anything, I can take a any number that is from 1 to infinity. Okay, so now I just need to check for the constraint of b, that is y. Okay, so the first thing that come into someone's mind is, for any number that is supposed b, this equation maximum time possible. This equation is only maximum time possible if for the numbers from 0, 1, 2, 3, ding ding ding, from to b minus 1. Okay, so for any number b, at most number of times, this equation is only possible for b minus 1 times. Right, what I'm trying to say, that let us suppose that b is 3, then I can only find a such that it can be either 0, 1 or 2, that its mode can be either 0, 1 or 2. Okay, because a mod b, and I can take a anything, but its mode always between 0 to 1, 0 to 2. Okay, so now what I see, that we get that only for a number b, we can find maximum b minus 1 elements, right? So for any element that is b, we can at most find b minus 1 element. Why I minus 1, why I am doing minus 1? Because if a mod b is 0, then it is impossible for a floor value to be 0, right? So it is impossible for a floor value to be 0. For example, let us take that 3 by 3. Okay, no, so why I am taking okay, wait a second. Okay, so why I am subtracting minus 1? Because b is 3 and we will get 3 elements that is between it. Okay, wait a minute. There's something fishy. Okay, so for 3 maximum we can get 3 modes, right? 0, 1, 2. Okay, so this value can be maximum of 3, 0, 1, 2. So when we see that, is for any value of a 0 possible, let us see that if I just take a equals to 2, then 2 by 3 is equals to 0. But a but this mode thing cannot be 0. This also must be 0. Okay, so this is only when 0, either either a is equals to 0, or a is a is divided by b, right? That is multiple of b, right? That is for example, in 3, either a is equals to 0, or a equals to 3, or a equals to 6. But 0 cannot be possible, because we have to just take from greater values from 1, right? Because a must be greater than or equals to 1, it cannot be 0. So we must not take 0. Okay, so that's why I'm just subtracting minus 1 from b. Okay, so if there are 3 elements, if my number is 3, then at most, if there is no constant on a, that only constant on a is that it must be greater than or equals to 1, then at most it will make 3 minus 1, 3 minus 1 special pairs. Okay, special pairs, because 0 is not possible, we will make only for 1 and 2. No doubt, no problem till here. Okay, so we saw that for any element b, it can at most make b minus 1 element. Okay, so now we will consider our next constraint, that is for x. So what we will see, we either the maximum answer possible is that either b minus 1, right? Or then the second maximum, that is the second constraint. When we include the second constraint, what we see is that we can find the maximum number, we can find the maximum number that can be divided by b. Okay, that can be divided by b and gives a mod b. Okay, so let us assume that we have 10 b, 1 2 3 4 5 6 7 8 9 10. we can take b from 10 to 10, that is our y is maximum is 10, and we can take b values from this to this. Okay, so now our a value, okay, for 1 we just ignore this case 1, because it's never possible for 1 to make such pair. We take any value of a, it will never make a by b a special pair. Okay, so now move on to the 2. So at max what we have seen, that at max it will make b minus 1, b minus 1 special pair. But now when we see that a has restriction, so I have to check whether 2 can make a special pair. So for 2 to make a special pair, there must be b plus 1 element. There must be present an element that is b plus 1, that is equals to b plus 1. A must be equals to b plus 1. Okay, so there must be an element 3 must be present. Is 3 possible? Let us take that 10 is equals to also 3. Okay, so when I check for 2, is element 3 is a can take the value 3? Yes, it can take the value. Okay, so now I will move to the next element, that is 3. Okay, so for 3, what is the element, what is the value of a such that it can make a special pair? Similarly for the case of 2, it will also take 4. Okay, because 3 plus 1, b plus 1. Okay, and similarly for each and every element we can see that it will make a pair, it will make a special pair if b plus 1th element is present. Okay, so if we iterate for all y, then it will give us TLE, very big TLE, right? It will give us TLE. So what we can do, we just use a simple math and we will calculate. Then if I am given with x, then I can find what is the maximum number possible, what is the maximum b possible, such that it can form a special pair with me, with that part, that its a is present in the x. Okay, so just try to understand that with x I can find the maximum value of b that can make a pair, that can make a special pair, and that with only one case, that we are considering only one case, that is b plus 1. Okay, so if my x is 10, so at max I can make a special pair with 9, right? Because 9 plus 1 is 10. So x minus 1, x minus 1 is my special pair. X minus 1 are the total number of pairs that are special for me. Okay, okay, okay. But I see one more thing, that x minus 1 gives me 9, gives me 9. But the total number of special pairs that are forming is 9 minus 1, because one cannot make a pair, right? One cannot make a pair. Similarly, when we move to the second mod, that is mod if a mod b is equals to 2, when we move to this case, then 2 can't make that, right? And when we move to the case a mod b equals to 3, then 3 can't make a special pair. Okay, okay, so for this I just need to add uh, x minus 1 minus 1. Okay, so either I can add x minus 1, or minimum whether if x is like 1000, then 999 I can't make 999, because I can't add 999, because if my y is like 10, if my y is like 10, then I can't go to the 999 element, right? So I just need to take minimum either of this or either of my y minus 1. Okay, so this is the first case. This is the first case when I need to either add y minus 1 or x minus 1. Okay, so it will give me that I can make at most with this y element. This, if this y is present, then uh, I can make these number of elements with special pair. Okay, and what the second term is saying, what this is saying, is saying that if my all a are possible, then it's the maximum number that I can it's the maximum y, it's the maximum b that I can take to make a special pair. Okay, so this is correct. Now I move to all the elements that can make a mod b equals to 2. Okay, so now what I see that now I just need to subtract x minus 2 by 2 minus 2. Okay, so in place of this I just need to put this. Why? So let us assume that our second number, that the maximum possible number whose a is present in this x limit. Okay, whose a is present in this x limit, that is 2 into b plus 2. Okay, so this is equals to a. If this a is present in a, if this a can't exceed the limit of x, then I can say this will definitely make definitely make a special pair. Okay, this will make a special pair, and then then similarly I can find this, that 2 into b plus 2 equals to x, and b can be at max equals to x minus 2 by 2. Okay, but now what I see that this will gives me again like 8 or 9, that particular number. Okay, so I will subtract 2 because first two number are not able to make a mod of 2 because it's already less than 2. Okay, so now we just need to add to our answer either minimum of y minus 1 and then x minus 1 divide by 1 minus 1, right? And then in the next step we will add again minimum of y minus 2 comma x minus 2 by 2 minus 2, right? Then again we will minimum. Okay, so when I just write I will just add these equation till either this thing equals to 0 or this thing equals to 0. If any one of these equals to 0 or less than 0, then I will just get the answer. Okay, that's the final answer. Okay, so if I just write this in a more mathematical way, so sigma I 0 minimum of y minus I comma x minus I by I minus I, right? And we will just move increment I till either of these two it becomes equals to 0. The code is also very simple for this problem also. Let's just code it out. Okay, so the problem says 9, the number of test cases, and then x and y. Okay, so int n, c in n, let's just take this t because it's test cases, and y t minus minus llx comma y c in x comma y. After this, what next step we need to do, we just declare an answer equals to 0, and we'll take two temporary element that is equals to x and that is equals to y. Okay, so while either of temp1 is greater than 0 and temp2 is greater than 0, we just need to add that to the answer. Then answer plus equals to minimum of temp1 comma temp2. Okay, and after this we just need to change our temp1 and temp2. Temp1 will be changed to, because it is x, so x minus I didn't declare I till now, x minus I minus I. Okay, so it's just the same thing, and our second temp2 will become y minus I. Okay, and now just declaring int I equals to 0, and we can see that just for the precaution that we should not cross I 1 2 3 4 5, because after this before this the answer must be there, because before I less than 10 to the power 5, either temp 1 or temp 2 will become 0. Okay, so now I just need to check whether first is my x comma y. So our first is must be x minus 1, x minus 2, and y is x minus 1 for the first case, because I just not need to take that x and y. I'm just using directly x minus 2, our first case, that is this one, x minus 2, x minus 2, that is x minus 1 and y minus 1. Okay, so let's just check for the answer. What it says. Oh, sorry, I just forgot to print the answer. It's compiling right. Okay, so I just print the answer. Why it's not printing? I just take the input 9, then x comma y. Okay, then answer equals to 0, temp equals to x minus 12, 2, temp 2 equals to y minus 1, then I equals to 0. Oh, it's not increasing because I'm not increasing I just need to increase I, right? Okay, so after increasing I, still not printing the answer. I don't know why. Okay, so let's see what's the error. Let int I equals to 0, I minus x minus I divided by I. So initially I is equals to 0. Okay, so right. So I just don't want to need I equals to 0. I should be equals to I just taken consider the case of 1, then I just needs to be 2, because now the first case is done and second case is I minus 2 divided by 2 minus 2. Okay, so let's see the answer. 10235 141 10235 141 53384 6 16966. Okay, so now the answer is correct. Okay, let me just submit the solution for the correctness of the solution. Okay, this, okay, accept. Now move to the next problem, that is problem number D. The problem number D is the simplest of all. Okay, okay. But the mathematics behind problem number D is very difficult. Okay, but the code is very simple. So in this we just need to observe two three things, and then the solution is very easy. Okay, so in this question what is given, that we have given a n by m matrix. Okay, and we just need to find another matrix b of I, where each element of b of ij is a multiple of a of ij. Okay, and the difference between two adjacent element must be a power of something k raised to the power 4. Okay, so let's see the problem. In the second problem, 4D problem. Okay, so we have given a matrix A, uh, n by m matrix. Okay, so this is A11, A12. Okay, so this is the given matrix, and I just need to find another matrix in which every element b of ij is a multiple of a of ij. A of ij divides b of ij. Okay, so what we can do, so before jumping to the question, let's see what's the constraint say. So in the constraint is just says that a of I is less than 16. So after seeing this constraint, we should always see that if the constraints are too small, then we must extract something from this opportunity. Okay, So as we have seen that a of ij is 16, and when we see that the total, when we multiply all elements from 1 to 16, that is LCM, when we find that least common factor of 1 to 16, we will get that it is 720 720. Okay, it is less than 10 to the power 6, and which is one of our condition that b of I must be less than 10 to the power 6. Okay, so what we can do, now we can just put all elements in our b of ij as 720 720 720. Okay, so now our first condition is satisfied, that it must be a multiple of a of ij. Now our second condition is that absolute value of the difference between the number. Okay, so the difference between these two must be something k raised to the power 4. Okay, so that must be and we know that a of ij is less than 16. Okay, so if I want to make this number a multiple of a of ij and raised to the power of k ki power 4, k power 4, okay, then what I can do, a simple basic solution that comes to one's mind is that I can just add 7204 7204 plus a of ij raised to the power 4, then it is also multiple of a of ij, and when I subtract this with this adjacent element, then it's also gives me an k raised to the power 4, right? It's just simple. Now what we need to do, we just need to put 7204 7204 in each cell, and just add a of ij raised to the power 4 in a chess like order, like just add in this one, and then this one, then this one, then this one. Okay, because if I just add in this and this also to adjacent element a of ij, if I add this one in this and this also, then the difference is not k raised to the power 4. Okay, you got it right, it's not that difficult. So I just need to check whether I plus j is even. If it is even, then just put 7204 720, and if I plus j is odd, then I just need to print 720 720 plus a of ij raised to the power 4. Easy. Okay, so this is the solution of problem D. I don't think that I just need to code this problem because the code is very simple. The main thing about this problem is its approach. What's the approach of the problem? And thanks for the video, thanks for the viewing, and if you like this video, then please like and share this video and subscribe to the channel. And you can also watch more content on the channel, but it's available in Hindi right now, and I will just try to make it in English. Okay, thanks for watching. Okay.